Hello everyone, today, let's learn together, gaseous pollutant control technology, basic knowledge. So, I will focus on the following three aspects. Control technology, foundation of gaseous pollutants in sluice. They are absorption method, adsorption method, and catalytic oxidation method, respectively. Firstly, let's take a look at the absorption method. At the synthetic ammonia plant, the raw gas for synthesizing ammonia contains carbon dioxide. How to separate carbon dioxide from feed gas? There are various gases present in the coking plant and coke oven gas. For example, carbon monoxide, hydrogen, ammonia, benzene, etc. How to separate ammonia from coke oven gas? At the sulfuric acid plant, pyrite can be roasted and oxidized to obtain sulfur trioxide. How to produce sulfuric acid from sulfur trioxide? To solve the above problem, chemical engineers have proposed a chemical unit operation absorption method. Operation of absorption is to use the composition of mixed gases. The solubility of each component in solvents is different. The operation of separating gas mixtures, called absorption operation. 1. There are three types of industrial applications for absorption. Firstly, separating mixed gases is also the most important application. 2. Gas purification. For example, in the gas emitted by a certain factory, containing toxic and harmful gases, does not comply with environmental protection emission standards. Choose appropriate solvents to absorb harmful gases. So, in the flue gas emitted by the factory, meet emission standards. 3. Preparation of liquid products. For example, using water to absorb hydrogen chloride gas. Prepare into hydrochloric acid. Using sulfuric acid to absorb sulfur trioxide. Preparation into sulfuric acid, etc. 2. Industrial classification of absorption operations, according to the presence or absence of chemical reactions, divided into physical absorption and chemical absorption. For example, sodium hydroxide absorbs carbon dioxide. Its chemical absorption, number of gases by solute, single component absorption and multi-component absorption, according to whether there is any obvious thermal reaction, divided into isothermal absorption and non-isothermal absorption. Absorption method, it's just using absorbents, mixing one or more components of a gas mixture. Selective absorption, separation process, called absorption. Physical absorption is included in the absorption method. The absorbed gas components are simply dissolved in the liquid. For example, water absorbs hydrogen sulfide gas. Its characteristics: no selectivity, low absorption. Chemical absorption, gas components absorbent, or dissolved in absorbent, certain active components. The absorption process that undergoes obvious chemical reactions. For example, sodium hydroxide absorbs sulfur dioxide. Features: selective, large absorption capacity. In air pollution control engineering, due to the large amount of gas in the exhaust gas that needs to be treated, characteristics such as low concentration. Pure application of physical absorption method for purifying waste gas. It is difficult to meet emission standards. In practical engineering, chemical absorption methods are often used to purify gaseous pollutants. 1. Basic principles of absorption method. The concept of absorption: absorbent, absorbent substance, absorbent solution. Physical absorption and chemical absorption. 2. Absorption equilibrium. Gas-liquid phase. Between gas and liquid. Existence of material transfer phenomenon. Gas phase components, soluble in liquid phase. Liquid phase components escape into the gas. This is a dynamic process. At a certain temperature and pressure, two-phase material transfer will achieve a dynamic balance. During dynamic balancing, between the concentrations of components in two phases, will follow a certain proportional relationship. This is the phase equilibrium of the gas-liquid system. (3) Absorbent. There's Henry's law in here. That's C equals H times P. The commonly used absorbents are shown in the table below. gas sulfur dioxide. During its absorption process, the commonly used absorbents are water, ammonia gas, sodium hydroxide, and sodium carbonate, and sodium sulfite, calcium hydroxide and calcium carbonate, calcium oxide and alkaline aluminium sulfate, magnesium oxide, zinc oxide, etc. So, the absorption process of gas nitrogen oxides. The commonly used absorption machines in China include water, ammonia, sodium hydroxide, sodium sulfite, and ammonium sulfate. Gas hydrofluoric acid. The commonly used absorbents are water, ammonia, and sodium carbonate. During the absorption process of gas hydrogen sulfide, the commonly used absorbents are water, sodium hydroxide and sodium carbonate. The absorption process of gas chlorine, commonly used are sodium hydroxide and sodium carbonate, and calcium hydroxide. The absorption process of gas hydrogen sulfide, commonly used are ammonia water, sodium carbonate, and diethanolamine, and cyclobutanol. The absorption process of waste gas containing lead uses acetic acid and sodium hydroxide. Waste gas containing mercury, commonly used are potassium permanganate, and sodium chlorate, and sulfuric acid and potassium iodide. The selection principle of absorbents, with large absorption capacity and high stability, low saturated steam pressure, having a suitable boiling point, low viscosity and high thermal stability, low corrosiveness, cheap and easy to obtain, commonly used absorption equipment. One surface absorber. Advantages of packed towers. The absorption effect is relatively reliable, strong adaptability to gas flow fluctuations, can be made of corrosion-resistant materials, simple structure, easy to make, low pressure loss, 490 pascals per meter tower height. Disadvantages of packed towers. 1. When the airflow passes through a large amount, the resulting flooding makes it difficult to operate. 2. During the absorption process of solids in the absorption liquid, precipitation generated, make the operation difficult. 3. The quantity of fillers is large, heavy weight, and inconvenient maintenance. 2. Bubble absorber. Advantages of bubble absorber. Bubble tower. 1. The tower is not easily blocked. 2. Low pressure loss. Disadvantages of bubble tower. Firstly, it is greatly affected by the airflow speed. When the airflow speed is too low, unable to perform as efficiently as expected. 2. When the airflow speed is too high, low efficiency of absorption. 3. Spray type absorber. Usually built into a tower shape. There is neither packing nor tray inside the tower, also known as a spray-type absorption tower, or it's called a hollow absorption tower. During operation, liquid is fed from the top of the tower. After installing various nozzles inside the tower, sprayed droplets or raindrops, gas enters from the bottom of the tower, liquid in the form of mist and rain droplets, close contact, and interact with each other, to enable the liquid to absorb easily soluble components in the gas. The solution flows out from the bottom of the tower. The second method, adsorption method, utilizing porous solid absorbents with large surface area, contact with exhaust gas, absorb harmful components on the surface, separated from the gas mixture, to achieve the purpose of purification, taking silica gel dehydration as an example. For example, multi-stage treatment adsorption method, usually designed at the end of the treatment process, as an advanced processing method. Adsorption method, widely used in environmental protection, for example, the recovery and purification of organic pollutants, low concentration of sulfur dioxide, purification of nitrogen oxide tail gas, commonly used porous solid absorbents for adsorption, mixing one or more substances in a gas mixture, concentrated on solid surfaces, and the process of separation from other components. The basic principle of adsorption. 1. The concept of adsorption, adsorbent, adsorbent and physical adsorption, as well as chemical adsorption. 2. Adsorption process, external diffusion, internal diffusion, adsorption, desorption. 3. Adsorption capacity, under certain conditions. On unit mass adsorbent, the amount of adsorbate adsorbed. 4. The factors that affect gas adsorption include 1. Impact of operating conditions. 2. The influence of the properties of the adsorbent, and the influence of the properties of the 3 adsorbents. 4. The effect of adsorbate concentration. 5. Characteristics of adsorption method. Advantages of adsorption method for purifying gas pollutants. 1. High purification efficiency. 2. Can recycle useful components. 3. Simple equipment. Short process, easy to achieve automatic control. 4. Non-corrosive. Will not cause secondary pollution. 2. Types and properties of adsorbents. 1. Activated carbon. 2. Activated alumina. 3. Silicone. 4. Zeolite molecular sieve. 5. Adsorption resin. 2. Selection of adsorbent. Basic requirements for adsorbents. 1. Has a large surface area and porosity. 2. Good selectivity. 3. Easy to regenerate. 4. High mechanical strength. Strong chemical stability. Good thermal stability. 5. Wide source of raw materials. Low price. 3. Regeneration of adsorbent. 1. Heating regeneration. By increasing the adsorption temperature, desorb the adsorbent, and regenerate the adsorbent. Almost all adsorbents, both can be regenerated by heating up. Different temperatures required. 2. Reduced pressure regeneration. By reducing pressure, advantageous desorption, regenerate the adsorbent. 3. Purge regeneration. To the regeneration equipment, inject non-adsorbed, purge air. Reduce the partial pressure of adsorbate in the gas phase, resolve it. 4. Replacement regeneration. Choose the appropriate gas, replace the adsorbent and blow it out. Then, perform redesorption of the adsorbent. 5. Chemical regeneration introduces a certain substance into the bed layer. Make it compatible with the adsorbed adsorbate material. Chemical reaction occurs. Produce substances that are not easily adsorbed, and then analyze it from the adsorbent. Catalytic oxidation method. Utilizing the catalytic effect of catalysts, convert harmful substances in exhaust gas into harmless substances. A waste gas treatment method for easily removable substances. 1. Catalysts and their performance. Catalyzer, significantly alter the rate of chemical reactions, and before and after the reaction, unchanging substance. For example, sulfur dioxide generates sulfur trioxide. Under normal pressure and low temperature conditions, when there is a catalyst, it reacts quickly, almost imperceptible without catalyst. Its main principle: reduce the temperature required for chemical reactions, accelerate chemical reactions, conduct catalytic oxidation reduction. Processing object, for example, hydrocarbons, sulfur dioxide, nitrogen oxides, etc. Its advantages: it is for pollutants of different concentrations, has a high conversion rate. Pollutants and mainstream gases do not need to be separated, avoiding secondary pollution. Easy to operate. Its disadvantage: the catalyst is relatively expensive. Exhaust gas needs preheating. The purification cost is relatively high. 1. Composition of catalyst. Active substance. Co-catalyst, carrier. Active substances is a component that contributes to changing the rate of chemical reactions. For example, vanadium pentoxide in catalysts. Co-catalyst, existing in the basic components of the catalyst. Additive, increase catalyst activity, like potassium sulfate, can promote a significant increase in the activity of vanadium pentoxide. Carrier, the carrier is the carrier of active substances and co-catalysts. Improve dispersion, the commonly used carrier is diatomaceous earth. Silicone, molecular sieve, alumina, etc. 2. The performance of the catalyst. 1. Catalyst activity, standard for measuring the catalytic performance of catalysts. 2. Catalyst selectivity, accelerate only one of multiple parallel reactions. 3. Stability of catalysts, the ability of a catalyst to maintain activity in a reaction. Selection of catalysts. 1. Extremely high purification efficiency, no secondary pollution generated. 2. High mechanical strength. 3. High heat resistance and thermal stability. 4. Strong resistance to toxicity, longest possible lifespan. 5. Good chemical stability, high selectivity. 6. Cheap and easy to obtain. Thermal stability, mechanical stability, and anti-toxicity. The aging of the catalyst inside this: the higher the temperature, the faster it ages. Temporarily poisoned, water vapor or other methods can be used to recover. Permanent poisoning means inability to restore activity. That's all for today's content. Thank you all.